All right, welcome back. This is for 1 a day 13 for Math 230, Calc 3. All right, in this example, we want to consider when t0 is equal to 0, we want to find the arc length along the cycloid r of t given by cosine of t, sine of t, and t. And we want to, for some between t0 and t, so we want to find the arc length of that, and then we also want to verify that the absolute value of the velocity of the arc length is equal to 1. All right, so let's go ahead and start by taking the derivative. So r prime of t, I usually use a dot, but with the vector notation that looks kind of weird, so I use the prime here. So we have the derivative of cosine is sine of t, negative sine of t, and the derivative of sine of t is cosine of t, and the derivative of t is just 1. So that gives us then the derivative, v prime of t, which is, of course, the velocity of t. Okay, and then what do we want to do? We find the arc length of this. So let's take the absolute value. So we have the absolute value of v, and that's going to give us, that is this dotted with itself, plus 1, so square root of negative sine t cosine t 1 dotted with negative sine t cosine t and 1. Okay, so you're going to get a sine squared t plus a cosine squared t plus a 1 squared, which is just 1. Here, this equals 1, so you get 1 plus 1. So the integral, or the absolute value of this, or the measure of this distance, is the square root of 2. Okay, and so that's really helpful because in the notes you saw that the arc length, L, is equal to the integral from s equals a to s equals b. This is the arc length parameterization, v ds. And so we can plug those in, and we know this is going from 0 to t. That was given up here. t0 is 0, so this is going from 0 to t. And we have that the absolute value is equal to the square root of 2. And then we have that's equal to d tau, or some dummy variable, dt prime if you want, whatever you want to call it. It's just a dummy variable. So you integrate out and you get that this is the square root of t minus 0, so it doesn't affect the integrand. Okay, and so that means that s is equal to t, which is equal to looks like this. T is equal to s divided by the square root of 2, which implies then that r of s is equal to cosine of s over the square root of 2 in the I direction, and then sine of s over the square root of 2 in the j direction, and then s over the square root of 2 in the k direction. Okay, now verify that this is indeed equal to 1. Okay, so that v of s is equal to 1 implies that we take the dot product of these together. Okay, so it's this dotted with itself, so you're going to have the square root of cosine I need to take the derivative of this first, so maybe I should do that in 2 steps. Yeah. Okay, so this is r prime of t, and that's going to give me, this is going to be 1 over the square root of 2 negative sine s over the square root of 2, and then 1 over the square root of 2 cosine square root of, s over the square root of 2, and then the square root of 2 1 over the square root of 2 for the z component. Okay, so this is the r prime, taking the absolute value of v, and so this is that with respect to s with the parameterization. Now that we have the v with respect to s, we can take this. So this is going to give me 1/2, because I'm multiplying this times itself, so you're going to get 1/2 sine squared s over the square root of 2 plus 1/2 cosine squared over s square roots of 2 plus 1 over the square root of 2 times 1 over the square root of 2 is 1/2. And this gives me, so this again is equal to 1, but we have a half in each case, so that's going to be the square root of 1/2 plus 1/2, which is exactly what we wish to square. It's the square root of 1, which equals to 1. So indeed, the absolute value of v, parameterized by s, has a length of 1, and we found that the arc length from 0 to time t with the arc length parameter is equal to square root of t. All right, I hope that was helpful, and I'll see you in the next video.